Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fawwaz bin Nazarudin, matric number 1192986. Today I will be present about Analemma phenomenon. Okay, so introduction. Analemma is a diagram or picture that shows the position of the sun in the sky as seen from its fixed location on Earth at the average time of the same sun, because the position change over the course of a year. The diagram will be resembled the number 8. Earth comes often display analemma. The north-south component of the analemma is the result of a change in the declination of the sun due to the slope of the Earth's axis of rotation. The east-west component is the result of the unequal speed of change of the rise of the drag of the sun, which is controlled by combined effects of the Earth's axial field and orbital eccentricity. Analemma, as it known today, has been used in conjunction with sundials since the 18th century to convert between visible and average solar time. Previously, the term had a more general meaning, referring to a graphical procedure for representing three-dimensional object in two dimensions, which is now known as orthographic projection. Although the term analemma usually refers to the analemma on the Earth's sun, it can be applied to the other celestial objects as well. So for the research problem, analemma, if asked to the general public about what is an analemma, most of them will answer not know. This is because the situation to understand the analemma itself is too complex, because the reading material on this analemma is too limited, as well as the procedure to conduct research on analemma is too complicated, as it will take a year to get clear and quality results. So, in this short study, researcher will conduct a study on analemma by using the source of manuscript and articles that have been published by relevant experts in the field of analemma. Discussion and finding. The definition of analemma in the dictionary is passing scale shaped like the number 8 that indicate the daily decline of the sun. In astronomy, an analemma is curve that represent the change of the outer angle of a celestial body from its average point position in space, as seen from the other celestial body. The term is used when the observer body appears, as seen from the body of the spectator, to move in manner that is repeated at regular intervals, such as once a year or once a day. The analemma is then closed curve which does not change, because the Earth's annual revolution revolves around the Sun in an elliptical orbit and inclined relative to the equatorial plane. Observer at a fixed point on the Earth see the Sun appear to move an analemma around the main position, taking to do so. The average position appears to rotate around the Earth once per solar day meaningful. Due to the rotation of the Earth, this daily revolution is not considered to get an average. Thus, the position of the Sun is at the same place in the sky at the same time each day, but not at other times. Therefore, if the position of the Sun observed in the sky is planned or photographed at the same time every day or every few days for a year, the eye detects an anomaly. So the slide show illustration 1, which is an example of an analemma form. So we're going to method for obtaining analemma. The analemma can be detected by guiding the position of the Sun as seen from a fixed position on the Earth at the same hour time each day for a year, or by plotting a graph of the Sun declination against the time equation. The resulting curve resembles a long, slender figure of egg with one lobe much larger than the other. These curves are usually printed on the Earth sky, usually is in the eastern Pacific Ocean, the only large tropical region with very little land. The long axis of the figure, the segment of the line joining the northernmost point in the Analemma to the southernmost is divided in two by celestial equator, which is approximately perpendicular and has a length twice the inclination, which is about 47 degrees, the component along the axis of real motion of the sun. The sun's declination through the year, the width of the figure is due to the time equation, and the extent to which the angle is the difference between the largest positive and negative deviation of a local solar time and from local mean time, when this time difference relate to an angle at 15 degree per hour and 360 degree in 24 hours. So this slide show illustration 2, which is example of extraterrestrial analemma. So there are three parameters that affect the size and shape of analemma: tip, eccentricity, the angle between the apse line and the solstice line. Seen from an object with a perfect circle of orbit and without an axial tip, the sun will always appear at the same point in the sky at the same time throughout the year, and the analemma will be the point. For object with round orbit but significant axial tip, the analemma is figure of 8 with the north and south lobe equal in size. For object with centric orbit but not axially inclined, the analemma will be a straight east-west line along the celestial equator. The north-south analemma component indicate the declination of the sun is latitude in the celestial sphere, or the latitude on Earth, where the sun is directly above. The east-west component indicate the time similarity or the difference between solar time and local mean time. In many analemma diagrams, a third dimension, the time dimension, is also included, indicated by a sign representing the position of the sun at various fairly close distance throughout the year. In the diagram, the analemma is drawn as it would be seen in the sky by an observer looking upward. If north is at the peak, west is to the right. They correspond to the sign of the time equation, which is positive to the west. The further west the sun is, compared to its average position, the fastest the clock in the sundial compared to the clock. If the analemma is a graph with a positive declination, which is north, plotted upward, the positive equation of the time, which is west, is plotted to the right. When an analemma is marked on a geographical ball, the west of analemma is on the right, while the geographical features of the world are shown with a west to left direction. To avoid this confusion, it has been proposed that the analemma on the ball should be printed with a west to left direction, but this is not done, at least not always. So this illustration trees show about example of an analemma bunch in the sky. The analemma that include a picture of solar eclipse is called euthymma, created by photographer Cheng E. Tezel and Tang Tezel, based on the Turkish word meaning eclipse. The, the analemma was plotted at seen as noon GMT from the Royal Observatory, Greenwich, which is latitude 51.48 degree north, longitude 0.0015 degree west. Due to the tilt of the Earth axis, which is 23.439 degrees, and the eccentricity of the orbit, the relative location of the sun above the horizon is not fixed from day to day when observed at the same hour time each day. Oriented Analemmas. Smaller lobes appear north of the larger lobes near the North Pole. The analemma will be completely upright, egg with a small lobe at the top, and only upper half of it will be visible heading south on south of the Arctic Circle. The entire Analemma will be visible. If you look at it at noon, it will stay upright and rise higher than the horizon as you move south. When you get the equator is directly overhead as you go further south, it moves towards the northern horizon and is then seen with a larger loop at the top. If on the other hand you can see Analemma in the early morning or evening, it will tip to one side as you move south from the North Pole. So illustration 4 show an example of calculation of Analemma. Human renovation of the concept of Analemma. Nowadays, we can see many countries racing to build the tallest tower or building in the world. For the record, the status of the tallest tower in the world is currently still held by the Burj Khalifa Tower, which is 828 meters, located in Dubai. In the world's science and technology, we are often served with out-of-the-box ideas that are sometimes difficult for us to describe, including Asgardia, a settlement in outer space that is considered a new nation. In fact, the idea of building a human settlement on Mars also seems illogical. Typically, towers, tall building will be built starting from the side and upward. The tower hangs from an asteroid. A New York design firm called Cloud Architecture Office has proposed a tower that will hang from an asteroid at an altitude of 31,068 miles from the Earth. The firm that produced this design concept, Cloud Architecture Office, is indeed an expert in visual concept design. Known as the Tower of Analemma, the building will hang majestically in the sky as it will hang on real asteroid cut with very strong cable and moving in eccentric geosynchronous orbit, moving in a number 8 shaped path. In the other words, it will be constantly moving. Residents and visitors who are in this building will travel daily between northern southern hemisphere with the starting point likely to start in New York City or Dubai. This illustration 5 shows an example of the Analemma Tower concept. The original idea of the concept, in 2015, mission Rosetta by the European Space Agency successfully landed on the surface of comet Churyumov-Gerasimenko, indicating that there is a possibility of interacting with smaller subjects in NASA. Asteroid redirect mission has been scheduled to send robots to collect rock from asteroids and then place the rock into stable orbit around the moon. In a similar way, the firm Cloud Architecture Office plans to use an asteroid equipped with high-strength cable that reach the Earth to hold skyscraper along its rim. The concept designer of Analemma Tower, Asta Asta Burudakic, claimed that the tower can be made durable and lightweight materials such as carbon fiber and aluminum. Advanced decable engineering are needed to achieve the cable strength required to support this tower structure. For the use of electricity, electricity will come from the solar panels that have exposure to sunlight continuously. Illustration 6 show an example of an asteroid holding an Analemma tower from an electromagnetic elevator. Rakesh said he envisioned the use of larger passenger drones allowing humans to move back and forth between the tower and Earth's surface, along with sophisticated electromagnetic elevators that facilitate movement and from the tower. Currently, there are proposals for the tower to build in Dubai, which has a long story of building tall and stylish skyscrapers at a lower cost than the US based skyscraper construction costs. When asked what inspired him for a project like this, Rurakich said, "Since humans no longer live in caves, our buildings are getting taller and lighter. We believe that in a few more years we will be free from the surface, freeing us from flood, earthquake, and dangerous tsunami. The Analemma Tower is a speculative idea of how this could be achieved at some point in the future. Although this Tower of Analemma is just a concept, it is quite interesting because it is the first time such an idea has appeared. So, in conclusion and recommendation. In conclusion, the phenomenon of Analemma is very important for humans because it can remind us about the time because the sun changes according to the day and month. Moreover, with the existence of this phenomenon of Analemma, we will always return to Allah subhanahu wa ta'ala and always increase our faith in Him as a Muslim. As recommendation, is it hope that reading material or article on this Analemma will be released with a more general and easy explanation for readers out there to understand. That's all from me. Thank you.